Hello friends, welcome to Basic Electrical YouTube channel. So in this video, I am going to explain solutions for Basic Electrical Engineering model question paper. So VTU has uploaded in the website 2 model question papers. So in that they will ask numericals. I am providing a detailed explanation for only numericals. Already we done a content for module 1 and module 2 covers totally 9 problems. Now in this video I am going to cover whatever the numericals asked under module 3 from both sets of question paper. So please watch the video with a lot of patience. Okay guys, don't forward it because I am going to explain how to solve this. If they change the data, what to do, everything I am going to explain in this content. So please, let's start with question number 1. Comes under module 1. See, this question asked in set 1 for 6 mark. Let's read the question. 4-pole 1500 RPM DC generator has lap wound armature having 32 slots and 8 conductors per slot. There are 32 slots. In one slot 8 conductors are there. Okay. If the flux per pole is 0.04 Weber, under this condition, determine the EMF induced in the armature. After, they asked another question, what would be the EMF induced if the winding is wave connected? So, very easy question. Okay, if you know one formula, you can easily take 6 marks in your pocket. Okay, so let's see in a lap winding. So, first we can do lap connected. See, in lap connected, number of parallel paths denoted by A is equal to number of poles. So, EMF generated equation is given by Eg is equal to pi p nz by 60 into A. Here pi is flux, P is number of poles, N is speed in RPM, Z is called total number of armature conductors. So Z is not given directly, they are given indirectly. So how to calculate total number of conductors? Whenever they are given slot and conductors per slot, from that data if you want to find total number of conductor means use this equation. Number of slots into conductors per slot. See, total number of conductor denoted by Z. So how many slots are there? 32 slots. Okay. And in one slot, how many conductors? 8 conductors are there. So if you multiply this, you will get 256. So these are the total number of conductors. Now you can substitute in the formula. Now Eg is equal to, what is the value of flux? 0.04 Weber into what is the number of poles? 4 pole. What is the speed of the machine? 1500 into what is the value of Z? You should take this one, 256. Okay, 256. Otherwise, you can write 32 into 8 here itself. That is also correct. Okay. Divided by, don't take 8 here. Don't take value of Z 8. That gives wrong answer. Divided by 60 into, what is A? A indicates what? Number of parallel path. What type of winding? Lap winding. So, A is equal to poles. Number of poles. What is the value of poles? 4. So 4 get cancelled. Please, you can do it in calculator. All this value will becomes 256 volts. So EMF generated, okay, in the lap wound armature is this much. Now the same question, if the machine is wave connected, what would be the EMF generated in the armature, in the winding? That is what they are asking. Okay. So now wave connected. See guys, in wave connected, number of parallel path will be always 2. Okay. You take value of A is 2 only for wave connected. A reason is there, that is higher level topic. You simply remember in wave winding, number of parallel path is equal to 2. That's it. Now Eg, you write again formula. Eg is equal to pi p nz by 60 into A. So what is the value of flux? 0.04. What is the value of poles? 4 poles. What is the value of speed? 1500. What is the value of Z? Total Z is 256 divided by 60 into what is the value of A? Very good, 2. So you can do it in calculator. You will get 512 volts. 512 volts. See, in lap winding we got 256 volt. With all the same data, if I change for wave winding collection, then we get higher generated voltage. See, this is one application of wave winding. That's why wave winding is used for high voltage generation. Okay, got it? Lap winding is used for high current generation. Okay, we don't have example in your syllabus to explain the application of lap and wave windings. So from this example, we can remember one application, wave winding suitable for high voltage application. Okay, blindly. Got it? So pause the video and then copy down. See, nothing is there. That's why you don't neglect problems. So there may be a problem simply by putting one formula. See, all data given in the question itself. I have taken all the data and put it here. Such type of problems will be there. That's why you must study the derivations. See, if you study derivation, 100% you can remember this equation. Got it? So how to solve problems on that derivations you practice. So you can easily score 10 to 15 marks in the problems in the entire paper. Okay, got it? Some problems will be there. It will be like thinking level. You try your level best. If didn't get, need not to worry. Okay. So pause the video that we can start next problem. Okay friends, now we can see second problem under module 3. So this question again asked in set 1 itself. See, this question is problem on EMF equation of transformer. See, whenever you are solving problems on EMF equation of transformer, you must remember these 3 formulas. Okay, that is more than sufficient. You simply, whenever you are solving problem on EMF equation, simply write this formula at one side and search the data. 100% you can solve it. Okay. So what is that formula? You must know the formula for K. K is nothing but transformation ratio. So formula for K is N2 by N1 or E2 divided by E1 or V2 divided by V1 or I1 by I2. So this is the equation for transformation ratio. So it is not visible. So I am overwriting here. So N2 divided by N1 is equal to E2 divided by E1, means the ratio of secondary induced voltage to primary induced voltage, that is also called K. The ratio of secondary terminal voltage to the primary applied voltage, that is also K. And the ratio of primary rated current to the secondary rated current is also called K. K can be calculated from any one of these 4 ratios. Okay, got it? So this is one formula you must remember. Okay. So next, second one, EMF induced in primary 4.44 F pi m N1. Primary turns, you take primary voltage. Okay. Similarly, EMF induced in secondary is 4.44 F pi m N2. This formula you must remember. Next is rated primary current, power divided by E1. Okay. Otherwise, power divided by V1. And rated secondary current, power divided by V2. See, in first year, okay, for all problems on EMF equation of transformer, you can consider E1 is equal to V1 and E2 is equal to V2. Actually, these two are not equal. Okay, that is advanced level topic. Definitely there will be a drop in the windings. Okay, your induced voltage never be equal to how much voltage you are going to apply. Okay, but in first year you are studying only the basic level, so you can do assumption. This assumption is valid for all problems on EMF equation of transformer in basic electrical engineering subject. Okay, E1 is equal to V1 you consider blindly and E2 itself V2. Okay, you must know only these formulas. Okay, If you know these formulas, you will get full marks on problems on EMF equation of transformer. Okay, let me solve this. So they given rating of the transformer. So they given power rating of transformer. How much? 250 kVA. Guys, this type of problems are very important. They can ask same problem only by changing the data. See, now they given some ranges here. 11,000 slash 415 volt. Whatever they gave in the question. First one is there, na? That is always even. What I said, that E1 should equal to V1. You take this is V1 value, and whatever the second, then that is E2, okay, or V2. Suppose if they given like this, 415 by 11,000, what is V1 voltage? First one is V1 only, and second one is V2 only. Got it? First is primary parameter, second is secondary parameter. Primary voltage, secondary voltage. Got it? Okay? I studied like this. 11,000 is primary, 415 is secondary. In question paper, if they come like this, if you interchange, then you are going to lose marks. Okay? First one is always primary, second one is always secondary. Got it? This concept you must remember. And they given frequency. How much? 50 Hertz. Transformer has how many turns on the secondary? 80 turns. Number of secondary turns is 80. So these are the data given. Using this data, they are asking calculate, first question, rated primary and secondary currents. So we can solve that. Rated primary current formula is what? I1. What is rated primary current formula? P by V1. So what is power? 250 kVA, no? You write K value is 10 power 3. It is in kilo range. Now what is V1? What is V1? V1 is 11,000. Okay. Otherwise you can write 11 into 10 power 3, or else you can write 11,000. Okay. Got it? You will get I1 value. Next is rated secondary current. Power divided by, what is the equation? Power by V2. So 250 into 10 power 3 divided by, what is V2? 415. So let me calculate this. Okay. So you also calculate and tell the answer to me. So 250 exponential 3 divided by 11 exponential 3. How much getting? 11, no, I typed here 110. Okay. Okay guys. So, okay, red is not working. Red. Okay, not coming. So let me write in black itself. 22.72. 22.72, this much current. Okay. Next to I2. You can do its same analysis. 250 kVA divided by 415. So we are getting around 602.409. You also got same answer? Okay, fine. That's nice. So first question is finished. 2 marks you got it just by remembering that formula. Okay. So next is number of primary turns. Number of primary turns. See guys, now we got I1 and I2 value now. By knowing I1 and I2, I can easily find value of K. So first to find K value. K value is I1 by I2. So what you will get? 22.72 divided by 602.409. So how much you will get K value? 0.0377. 0.0377. See, you write K value after a decimal up to 4 digits you write. It will give accurate result. Okay, that's why. Sometimes you will get K value exactly 2 or exactly 1. That is fine. Sometimes lot of digits you will get. You take up to 4 digits. Got it? Okay. Suppose if your calci shows exactly 0.03 means you cannot write 4 digits. Next digit will be 00. Okay. Please write 4 digit. What is the reason? To get accurate result. That's it. Now I got K value. I got K value. Now you can take it. So wait, I will change that color of the pen. I will take this green only. you take this ratio. See why I am taking that one means, see N2 by N1 is equal to K. I know K value. They given N2 value. By knowing K and N2, I can easily find N1. See how simple it is. So N1 can be written as, because that is the question they asked, number of primary turns. Then from this one, how we can write N1? N2 by K. What is N2? Number of secondary turn is 80. What is the value of K? 0.0377. Okay. Let me do it, that one. 80 divided by 0.0377. So getting around 2122. So 2122 point something you will get. You write exact integer. This many number of turns in the primary. This many number of turns in the primary. That question also over. Next is maximum value of flux in the core. Okay. So to determine maximum value of flux in the core, now you can take either this formula or this formula. So I am going to take this one. E1 is equal to 4.44 F pi m N1. F pi m N1. What is the value of primary voltage? 11,000 volts into 4.44. What is the frequency? 50 is given in the question. Pi m only I need to calculate. You write that as it is. Into what is N1? N1 is how many turns? 2122 turns. So from this you can calculate the value of pi m. So how much you will get? That we can check it now. Do along with me. 50 into pi m into 2122 to solve equals, yes, getting 0.0233 Webers. So this much flux is getting from the transformer. See guys, you can take this one also, second equation. See, from second equation also I am going to get same answer. Check out here. So E2 is equal to 4.44 F pi m N2. What is the value of E2? 415. E2 is 415, no? 4.44 into frequency is 50. What is the value of pi m? That itself I need to calculate. What is the value of secondary turns? 80. Guys, from this equation also you can solve it. You will get same answer. Pi m is 0.0233 Webers. See, why we are getting same flux from both the equation? That is the work. That is a speciality of transformer, because transformer is a constant flux machine. It is a static device. It is constant flux machine and it operates at constant frequency. That's why we get same flux if you take either primary equation or secondary equation. So we completed maximum value of flux in the core. Last one is voltage induced per turn on secondary. Okay. So for last one I am going to write here. Okay. Voltage induced per turn. See, voltage induced per turn. Which side they asked? Secondary, no? So secondary means you write secondary voltage. What they are asking? Per turn. Turn you write secondary turns. So this ratio they are asking. Voltage induced per turn on secondary. Same question in the main paper. If they ask voltage induced per turn on primary means, what you are going to write? You must write E1 by N1. That's it. So that's why model question papers you need not to neglect. You have to practice in depth. Okay. You try to change all the data and practice one. So what is E2? 415. What is the value of secondary turns? 80 turns. Secondary turns 80. 415 by 80. How much you will get? How much? 5.1875. Very good. 5.1875 volts. Okay. Got it? See guys, if you taken voltage induced per turn on primary also, your answer will be same. Your answer should get 5.1875 volt only. Okay. Whatever the rating of transformer you have designed, you must get same voltage per turn in both primary as well as in secondary. Okay, got it? And another concept in transformer is whether primary or secondary. In transformer, power will be same. That's why, see in this equation I1, I not written P1 by V1. I written P by V1. And I2 is equal to P by V2. If powers are different means I could have write P1 by V1, P2 by V2. But concept is different. In transformer, powers are same in both primary and secondary. In transformer, voltage induced per turn is same in both primary and secondary. In transformer, flux is constant, frequency is constant. What is changing then? Voltages and currents are changes. See guys, observations. Voltage 11,000 volt. Higher the voltage. If primary voltage is higher, you will get primary current lesser. Okay. If voltage is lesser, you will get what is this voltage? Secondary voltage. Then you will get secondary current higher. Current and voltage are inversely proportional in transformer. See, all these points are very much required, okay, to solve problems in a confident manner. That's why don't forward the video. If you have a time, please watch it only once. Only once watch it and understand properly. Okay, got it? Final verification. You take E2 by E1. See, this is E2. This is E1. Calculate. You will get K value. Same like this. Okay. Now, V2 by V1. Because I told E2 is equal to V2, E1 is equal to E1. Obviously, you will get same answer. Next is I1 by I2. You calculate. You will get same ratio. Next is N2 by N1. N2, where it is N2? N2 is 80. Divided by N1 is how much? 2122. N2 by N1 you do it. Again you will get same value of K. Whatever you do it, finally this is very important step to cross verify your answers. I hope every clear cut you understand how to solve problems on EMF equation of transformer. Okay, I could have given direct solution for this. Okay, but same problem comes, many will solve. Otherwise, if they change the data, so they cannot solve it. So please watch the video with lot of patience. Okay. Okay, friends. Friends, please pause the video and then copy down. Okay, friends. This problem asked in model question paper, it is a difficulty level. Okay. If you know the subject, then only you can touch this problem. Okay. See, you have studied types of generators and types of motors. Okay. This question covering both the topics. They covered both type of generator as well as motor. Okay. Two topics asked in one question. So that is VTU is giving indication we are going to ask such type questions also. There will be a difficulty questions. Okay. So the students who are good understanding the subject, so they can touch this type of problems. Okay, need not worry. If same question comes, you can crack it. You can enjoy. So let me solve this. A shunt generator. Okay, what do you mean by generator? Mechanical to electrical. So mechanical input is given to generator. It going to produce electrical output. How much output is producing? It producing 50 kilowatt at a voltage of 250 volts. At a terminal voltage of how much? 250 volts. So the shunt generator delivers 50 kilowatt 250 volt and runs at, so this generator is running at 400 rpm. Okay. The armature and shunt field resistance are 0.02. What is the value of armature resistance? 0.02 ohms. And what is the value of shunt field resistance? 50 ohms respectively. So this is the data given. They are asking calculate the speed of the machine running as a shunt motor. It is generator. If it runs like a shunt motor, what could be the speed under such condition? That is the question asking. Calculate the speed of the machine running as a shunt motor and taking the what is required for motor? Electrical is required. Input is electrical, output is mechanical. Now whatever the output I got, electrical output from the generator, 250 kilowatt and 250 volt, this supply I am giving to the shunt motor. Okay, that's why they are given what is the speed of the machine running as a shunt motor and taking 50 kilowatt input. See, I am giving 50 kilowatt of input to shunt motor at this voltage. Means generated output voltage giving to the motor input, because motor required electrical. That's why I am giving supply to it. Under such condition, when motor is connected to this supply voltage, what speed it runs? That is the question they asked. Along with that, they are asking, allow 1 volt for contact to drop. Okay, brush contact to drop. Okay, means this what I written, no, this box and this box, these are called brushes. The brushes are made up of, it is having some resistance. Carbon brush or graphite brush have some resistance. Okay, you might have studied in construction of DC machine. Okay, that is very important. See, now these brushes will going to collect the voltage. While collecting the voltage, okay, there will be small voltage drop in the brush. They given in one contact 1 volt drop. How many contacts are there? Minimum contact is 2 contacts. Okay, got it? Now we can solve this. So first you find how much voltage generated in the machine. Calculate the voltage generated in the when machine has a generator. So now find out load current. See, they given output voltage and output power. Using this data, find load current. What is current formula in terms of power and voltage? Power by V. What is output power? 50 kilowatt. 50 10 power 3. What is the voltage? 250. Do it in your calculator. You will get a 200 ampere. Next, calculate shunt field current. Calculate ISH. What is ISH? See, these two are connected in parallel. Assuming load is having some resistance, that is not required for us. These two are parallel means same voltage will be there now in this RSH also. So VT by RSH. Equation is VT by RSH is, VT is how much? 250. What is RSH? Shunt field resistance is how much? 50. 250 by 50, you will get a 5 ampere. So armature delivers current. This armature current flow till here. After that, this current will divide in shunt field winding and load. So therefore, this current equation will be, so IA current equation will be IL plus ISH. What is IL? 200. What is ISH? 5. So what is your armature current? 205 ampere. This much current is generated by the machine. Okay, in that 5 ampere is passing in field winding and 200 passing in load side. Okay, that is the meaning. So now find the generated voltage. See, generated voltage formula for shunt generator is EG is equal to VT plus IARA plus V brush drop. Okay, V brush, okay, drop. Got it? Now I am entering below this. You write it down. So below that, so EG is equal to, what is the terminal voltage? 250 plus, what is armature current? 205 multiplied by, what is armature resistance? 0.02 plus voltage in the brush drop contact. How many brush drop contact? They given 1 volt in one contact. We have 2 contacts. So write total brush drop is due to contact is 2 volts. Do this in calculator. So let me check how much we get. 205 into 0.02 plus 2. So getting 256.1 volts. So I am getting generated voltage EG is 256.1 volt. Okay. See, till here all the calculation related to generator side. So now do it for motor side in the same way. See, in motor apply KCL at this node, apply Kirchhoff current at this node. What is the current entering? IL. What are the currents outgoing? ISH and IA. So IA plus ISH. Okay. From that you find IA value. So IA will be IL minus ISH. What is IL? Using this data, that is input current, line current. Okay. power by voltage you get current. We already done this side. That is 200 ampere, that is load current, sorry, line current. And what is ISH? 5 ampere. 250 by V by RSH is ISH, 5 ampere. 200 minus 5, how much you will get? 195 ampere. So this is the value of armature current when this machine runs at shunt motor. When it running a generator, it is delivering 205 ampere. When it acts like a motor, the armature current is 195 ampere. Okay. Now find back EMF in motor. In motor, generating action will be there. That is called as back EMF. Okay. So back EMF formula for motor can be written as, okay. Otherwise, you write voltage equation. You write voltage equation of motor. V is equal to EB plus IA RA plus V brush drop. Okay. So what is the voltage connected to the motor? 250. I need to find what? I need to find what is generated in the motor. That is back EMF. So EB plus, what is the armature current? 195. What is the value of resistance? 0.02. How many brush drop? How many contacts we have? 1 and 2. Minimum 2 contacts. So plus 2. So from this you find out back EMF. From that you calculate EB. So let me check it how much we get. So do it properly. So don't be hurried. So I done it. I got 244.1. I hope you too got same answer. So I'm going to write that value itself, 244.1 volt. So this is the generated voltage in the motor that is generated due to generating action in a motor. Now finally, when it runs like a generator, the speed of the generator is 400 rpm. Now if I connect this ratings to the motor, what speed it runs? That is what the question. For that we have to relate voltage with the speed. So we know that induced voltage in the generator is proportional to the speed. Okay, voltage is proportional to the speed. Now you take generated voltage and in the generator and generated voltage in the motor, that is EB. Otherwise you can take EMF induced in motor itself. So not required, you take EB only. Okay. So proportional to, okay, motor's generator speed is NG. For corresponding EG, corresponding generator speed. For corresponding EB, corresponding motor speed. EB taken place in motor. That's why I am written motor speed NM. Now this is the data. E is proportional to N. So therefore you write equating sign. You enter all the values. What is EG value? 256. EG, yes, 256.1 divided by what is EB? 244.1 is equal to what is generator speed? 400. Then you can easily find motor speed. By solving this, you will get a motor speed. See, if voltage reduces, obviously speed reduces. Okay, got it? So let me solve this. So 256 divided by 1, sorry, 256.1 divided by 244.1 is equal to 400 divided by alpha x. So by solving this, we are getting speed as, how much you got? Okay, 381. Okay, that's nice. So final answer is 381.25 RPM. See, this problem is difficulty level. You have to practice this type of problems. Okay. If you try difficulty level, you are in the range of scoring 80 plus. If you are trying such type of problems, you can easily cross 80 plus. Okay, or 90 plus. Okay guys, pause the video and then copy down. Okay dear students, last problem in module 3, numericals. So again they asked a problem on shunt motor. Let me read the question. A 4-pole 500 volt shunt motor. So I written shunt motor diagram has 720 wave connected conductors. Okay. See, whenever they given wave connected, what you must take? A value is equal to 2. And now they given direct value of Z. Z itself 720 given. Z value is 720. Conductors connected in armature. The full load armature current is 60 ampere. So armature current value they already given. 60 ampere is given. You need not to calculate. What is actually IA? IA is what? IL minus ISH. So IA itself already given. So need not to find RSH and ISH. Okay. That data is not required. Okay. And the flux per pole is, they given flux per pole is 0.03 Weber. The armature resistance is, they given the value of RA is 0.2 ohms. And the contact drop 1 volt per brush. So this is one contact, this is another contact. What will be the total contact drop? 2 volts. Calculate the full load speed of the motor. They are asking what is speed of the motor. See, you write first this equation only. EB is equal to pi p nz by 60A. So I want to find speed now. To find the speed, I want to know back EMF. Okay, without knowing back EMF, you cannot do it. See, flux is given, poles given, conductor given, 60, A value is known. But by knowing two unknowns, you cannot find. So, how to find the back EMF? Back EMF is calculated using voltage relation of shunt motor. That is this equation. For a shunt motor, back EMF equation is this one. V minus IARA minus V brush drop. If brush drop is not given in the question, you can delete this. Then back EMF equation will be only this much. V minus IARA. If brush drop given, then only take this term. If brush drop given, then only take. Otherwise, neglect that part. Okay. So now enter all the values. What is V given? 500. What is armature current? 60. What is armature resistance? 0.2. Minus. What is the V brush drop? 1 volt per brush. They given here 1 volt per brush. So two brushes are there. One brush and two brush. So you write minus that 2 volts. Do this in calculator, you will get 486 volt. So in this is unknown and speed is unknown. Okay. All data is given in the question itself. So by now I got EB value. Then I can easily find N value. So from this we can write equation for N is EB into 60 into A divided by P pi Z. Okay. Enter all the data. Back EMF 486 and 60. What is the value of A? A is equal to 2. Why? Wave connected. Divided by poles. How much? 4 poles. Okay. What is the value of flux? 0.03 Weber. And Z is how much? 720 conductors. Please do it in calculator properly. You will get 675 RPM. So by this, okay, module 3 numerical solutions for model question papers for basic electrical subject students who are studying under VTU is completed. So pause the video, copy down as neat as possible. So tomorrow I am going to, in the next video I will upload module 4 numericals and module 5 numericals. Okay, together side by side I will apply. Okay, first I will upload module 4. Within 30 minutes gap I will upload module 5 numericals. Okay, got it guys? So please like, if you understand, if it is useful for your exam, please give a like to this video and also other videos. Okay, and share this content to all your friends so they can go through. See, if you listen the explanation, don't copy question, pause the video when I went to side, okay, taking photo, copy. That means if you got same question exam, you can easily solve it. Listen my explanation so that you can easily understand the topic. If any changes they made it, you can easily do it.